Good evening, children. Good evening, online children.
Good evening, ma'am.
Good evening.
Good evening.
Good evening.
Good evening.
Questions will come to that later. Okay. Good evening. Okay, so in this chapter, coordinate geometry, you'll be learning two different concepts. One is about the distance formula, and the other is about the section formula. All right. So, what is distance formula, and when do we have to use the distance formula? So distance formula is used to find the distance between 2 points in a Cartesian plane. So Cartesian plane, we all understand the x-axis and the y-axis. The plane on which the x-axis and y-axis lie is called the Cartesian plane. Now on this Cartesian plane, say you have 2 points A and B, and you want to find the distance between these 2 points A and B. And how do you find the distance between the 2 points? It's the straight line connecting the 2 points. Okay, what is the distance between the 2 points? It's a straight line connecting the 2 points. The distance between the 2 points is also the length of the line segment AB. Now, point A, point B in the Cartesian plane. Cartesian plane. Okay, Cartesian plane. All right. So now we have these 2 points A and B lying on the Cartesian plane, and we wish to find the distance between these 2 points A and B, which is the length of this line segment. The length of this line segment AB is the distance between the 2 points A and B. Now we have a formula which is called the distance formula, which is used to find the length of this line segment AB, which is also the distance between the 2 points A and B. Both are the same. Distance between the 2 points A and B is the same as the length of the line segment AB. Okay. So we have a formula, and the formula goes like this. Now before that, let's say the coordinates of point A, okay, are given by x1, y1. And the coordinates of point B are given by x2, y2. What is it normally? X, y, right? These are called ordered pairs. These are called ordered pairs. In a Cartesian plane, the address of the points are ordered pairs. Like we say, no, A is given by the address 3, 5, B -7, -8. Now these are ordered pairs. Ordered pairs. The address of every point lying in the Cartesian plane, okay, is called an ordered pair because the order is important. 3, 7 and 7, 3 are not the same. 3, 7 is different from 7, 3. That's why ordered pair. The order is important. Okay, that's just an information. Now coming back to this. So say A is given by the address x1, y1 and B is given by the address x2, y2. Now let's see the distance formula with the help of which we can find the length of the line segment AB. Okay, so AB is equal to, okay, with respect to this line segment, AB is equal to root of, okay, so I'm going to write it in words, children. I'm going to write it. So let me take away this section formula from the slide. That's the next thing we'll be studying. So we have 2 points. We have 2 points A and B. A x1, y1, okay, and B x2, y2. So the distance formula, or AB is equal to square root of, I'm going to write the formula in words. difference between abscissa the whole squared plus difference between ordinates the whole square. Or you can also write it as AB is equal to square root of difference between ordinates the whole squared plus difference between abscissa. What's the plural of amoeba? Amoebae, correct? So like that. So difference between ordinates the whole square plus difference between abscissa the whole square. So we know abscissa meaning the x coordinates. Here the x coordinates are x1 and x2. X1 and x2 are the x coordinates of the 2 points. Y1 and Y2 are the y coordinates of the 2 points. Okay. So x1 and x2 are referred to as the abscissa and y1 and y2 are referred to as the ordinates, plural. So now, because it is plus in the middle, the order is not important. Because if it's a minus here, then you cannot exchange it and write it. Okay, but because it's a plus in the middle, you can write it like this also. Okay. Now let's use it. Now, when we say difference, now another thing is A minus B is not the same as B minus A. Please listen, even if you've learned it in school already, please listen to this. But A minus B the whole squared is equal to B minus A the whole squared. Because expand A minus B the whole squared, you get A squared plus B squared minus 2AB. Expand this one, B squared plus A squared minus 2AB. You expand both, you'll get the same terms. You'll get A squared B squared minus 2AB, B squared A squared minus 2AB. The same. And even if you take a numerical example, like 4 minus 7 the whole squared and 7 minus 4 the whole squared, both have the same value. 4 minus 7 is minus 3 the whole squared, 9 plus 9. 7 minus 4 is 3, 3 squared is 9. Both are the same. A minus B is not the same as B minus A, but A minus B the whole squared is the same as B minus A the whole squared. Okay. So A minus B the whole square is the same as B minus A the whole square. So what is it? Difference between abscissa the whole square. So you can write x1 minus x2 the whole square, or you can write x2 minus x1 the whole square. Order is not important. Difference between abscissa. Which are the abscissa? X1 and x2. X1 and x2 are the abscissa. Now, which one to write first? X1 first or x2 first? Any order you can write because it's, x1 minus x2 the whole square. The difference is squared. So the order is not important. So AB is equal to square root of x2 minus x1 the whole square plus difference between the ordinates. Which are the ordinates? Y1 and Y2. Their difference. So you can write y2 minus y1 the whole square. Or see, it's not that if you write x2 here, you should write y2 here. No. You can write y1 here. So get it very clear. Y1 minus y2 the whole square. So get it very clear. You should just write the difference in the bracket. Difference between the x coordinates in the bracket. You can write x1 minus x2 or x2 minus x1. Any order. Whole square. Plus, in the next bracket, you must write y1 minus y2 or y2 minus y1. Not that in the first bracket, if you write x2, you should write y2 here first. Nothing like that. Any order you can write. So in the next bracket, you must write y1 minus y2 or y2 minus y1 the whole square. So in the formula, you're basically going to write, you can write x2 minus x1 the whole square, or you can write x1 minus x2 the whole square. You can write y1, you can write y2 minus y1 the whole square, or you can write y1 minus y2 the whole square. Pick anything. So now the distance formula AB is equal to square root of, okay, So if you want to write x1 minus x2 the whole square plus, you can write y2 minus y1 the whole square. It's correct. Or you can write y1 minus y2 the whole square. So the order, even whatever order you write, the value is going to be the same because a minus b the whole square is the same as b minus a the whole square. Okay, so the distance formula is given by square root of difference between abscissa a the whole square plus difference between ordinates the whole square. Abscissa are x1 and x2. Ordinates are y1 and y2. Difference means x1 minus x2 or x2 minus x1. There y1 minus y2 or y2 minus y1 and square them. And you can again write the ordinates different first. Like y2 minus y1 the whole square you can write first, and then you can write x1 because it's plus in the middle, you can write that also in any order. So I've given you the formula and words. So we'll just write one of it now. Write one of it. So the distance formula is equal to square root of x2 minus x1 the whole square. Normally in the books it's like this. So x2 minus x1 the whole square plus y2 minus y1 the whole square. There's a distance formula, and this is used to find the length of a line segment or the distance between 2 points on the Cartesian plane. There's point P, there's point Q. What is the distance between the 2 points? Distance formula. There is point P, there is point Q. What is the length of the line segment PQ? The same thing, distance formula. All right. So this is when we use the distance formula. Next, section formula. No, I haven't given you time to write, children. We'll just discuss the next one. Next is the section formula. So we'll understand the different components in the section formula. So in the section formula, basically you have a line segment. Okay. A line segment on the Cartesian plane. So it need not be a straight line like this. It can be inclined. Okay. So we have a line segment. We'll just call it P and Q. Okay. And the coordinates of P, x1, comma, y1. The coordinates of Q, x2, comma, y2. There is a point, say R, lying on PQ, dividing PQ in the ratio m is to n. In some schools, we say m1 and m2. So not to get confused. Okay, so what do we have here? In the Cartesian plane, we have 2 points, P and Q. P given by x1, comma, y1, Q given by x2, comma, y2. There is a point R, whose coordinates are given by x, comma, y. R, x, comma, y lies on PQ, lies on the join of PQ. R lies on the join of PQ, dividing PQ in the ratio m is to n or m1 is to m2, whatever your teachers told you. Okay, that means PR is m parts and RQ is n parts, or PR is m1 parts and RQ is m2 parts. The ratio. The ratio is always PR, RQ, that order. Or it will be specified in the question. If not, if it's given like this, it is PR and RQ. Or things will be clear in the question. So now these are the different components of the section formula. So you have 3 points actually, P, Q, and R. R lies on the join of P and Q. And you can see their coordinates. Okay. And you can also see the ratio m is to n or m1 is to m2. Now the section formula. The direct application of the section formula. See, what do I mean by saying direct application? Okay, let me just make that clear first. Now we have, say, volume of cylinder is given by the formula pi r square h square units. Sorry, cubic units. Okay, so volume of cylinder is equal to pi r square h cubic units. Now, when you're given the values of R and H, you can substitute and find the volume of the cylinder. But this is not the only application of this formula, right? If you're given the value of, if you're given meaning the volume of the cylinder and the value of R, you can substitute and find H. What are the three different unknowns in this formula? In this formula, what are the three different unknowns? The unknowns are volume, radius, height. These are the three unknowns. Given any two, you can find the third one. Because pi is a constant. The three unknowns are volume, radius, and height. Given the values of any two, you can find the third one. If you're given radius and height, you can find volume. If you're given volume and radius, you can find height. If you're given volume and height, you can find radius. But what's the direct application of this formula? This formula is to find volume. Volume of cylinder, that's how it's introduced to you, no? So the formula to find the volume of cylinder is pi r square h, cubic units. That's how it's introduced to you. That means we understand, okay, to find volume of cylinder, I should use this formula. But that's not the only application of this formula. You can also use this formula to find radius given volume and height. In the same way, the direct application of the section formula. So here the direct application of this formula is to find volume given the radius and height. In the same sense, I'm saying the direct application of the section formula is to find the coordinates of R. Okay, I'll just write. So this is just for us to understand. It's not in the books like that, direct application. So just a second. All right. So this formula is designed to find the coordinates of R. That is, the formula is designed to find the coordinates of the point of division. This is called the point of division. This is called the point of division. Because this point divides the line segment PQ. All right. So the direct application of the section formula is to find the coordinates, the address of the point of division R. That's why the formula is designed. But using this formula, you can find other things also. That is, if you're given the address of R, then you can use this formula to find some of the missing component. Exactly like we understood with the volume formula. If you're given volume, you can use the same formula. If you're given volume and height, you can use the same formula to find radius. The same way here, what's the direct application of the section formula? To find the coordinates of R. And what is R? It's called the point of division. Because R is dividing the line segment PQ in the ratio m:n. So R is called the point of division. And the direct application of the section formula is to find the coordinates of R, the address of this point R. Okay, so section formula, I'll write SF is equal to. So if you're using, if the section formula is about finding the address of R, then you should find the X coordinate and the Y coordinate, right? Let me write that. Section formula is used to find the coordinates of the point of division. So now we know that there should be a line segment, and then there's this point R lying on the line segment. So we know all that. So the section formula is used to find the coordinates of the point of division. Here it is R. Okay. Now, X coordinate. Don't write notes. I'll give you later. We're just trying to understand. X coordinate of R is equal to. Okay, we have a formula or an expression to find the X coordinate of R. And we have another expression or formula to find the Y coordinate of R. So now the X coordinate of R is given by mx2. It's a cross multiplying mx2. See, when you're finding the X coordinate, no, you'll use only x1 and x2 with the ratio. When you're finding the Y coordinate, you'll use y1 and y2 with the ratio. What are the different things you see here? See, this x coordinate of r only is x. That is x. That x coordinate of r is x here. Here it is x. Right? Don't sleep. Okay. Okay. The AC blower is hitting your eyes directly. Yeah, I could make out that. Would you like to change your place or you want me to turn it off? Huh? Yeah, thank you. Or if you find you can move that side also. அப்படியே அந்த எண்டுக்கு போனாலும் உங்களுக்கு காத்தடிக்கும். X coordinate of r, which is here x is equal to. So I told you, you will be using the ratio. What's the ratio? M and n. M is to n or M1 and M2. The ratio is M1 is to M2 or M is to n. Okay. So you'll be using the ratios. I'm using M and n. Okay. M is to n. You'll be using the ratio M is to n and x1 and x2 to find the coordinates of, to find the x coordinate of r. You'll be using the ratio M is to n and y1 and y2 to find the y coordinate of r. Okay. What all we have here? We have x comma y, right? X is the x coordinate of r. Y is the y coordinate of r. Okay. Okay. Now we have to find x, we have to find y. We are writing the formula for that. To find x, what will you use? You'll use a ratio m is to n and the x coordinates x1 and x2. To find y, you'll use a ratio m is to n and the y coordinates y1 and y2. Okay. So see the x coordinate of r, which is x, is mx, like cross multiplying mx2 plus nx1 by m plus n. You can just write this what I told you now. I'll just write this again. I won't say it, but I'll just write it, okay? Okay, I'm just writing it again to find the x coordinate. So you'll use a ratio and x1 x2. All right. So the formula is mx2 plus nx1 by n plus n. This will give you the x coordinate of r and the y coordinate of r, which is y. Here y is equal to my2 plus ny1 by m plus n. If you're using m1 and m2, please substitute that accordingly. m1 x2 plus m2 x1, that becomes like a tongue twister. What do you use? And those have learned m1 m2 mn m1 m2. Okay, m1 x2 plus m2 x1 by m1 and plus m2. You can just write this and make the formula. So this is the expression. This is the expression or this is the formula to find the x coordinate of the point of division. This is the expression or this is the formula to find the y coordinate of the point of division. All right. Let's do it again. So what are the different things we have in the section formula? The 2 points, let's call it A here, x1 comma y1 and B x2 comma y2. Okay, so we have 2 points A and B with address x1 y1 and x2 y2 respectively. Now we have this point C lying on AB, dividing AB in the ratio m is to n. The address of C is called the point of division and it's given by the address x comma y. The direct application of the section formula is to find the coordinates of C, which is the point of division. Okay, so x is equal to, what is x? The x coordinate of C. Y is the y coordinate of C. So to find x, you'll have to use what? the ratio m is to n, and the x coordinate x1 and x2. So x is equal to mx2 plus nx1 by m plus n. To find the y coordinate of the point of division, we use the ratio with the y coordinates y1 and y2. So y is equal to my2 plus ny1 by m plus n. All right. Okay. So earlier we had also something under the heading area of a triangle, where we had this formula to find the area of a triangle. That was one big chunk, but that's now removed from the syllabus. So we only have these two, the distance formula and section formula in this chapter, coordinate geometry. All right. Now we need to understand the midpoint formula, okay, which is basically a derivative of the section formula. Section formula lenda midpoint formula vardu. Okay. Midpoint formula. Midpoint formula arises from the section formula. This one arises from the section formula. Okay, so same situation, A, B, x1, y1, x2, y2, except that C is the midpoint of AB. That means it divides AB in the ratio 1:1. It divides AB in the ratio m is to n. But it's a midpoint, right? So the ratio is 1:1. C is the midpoint of AB. Therefore, m is to n is equal to 1:1. Okay. Now, same section formula. X is equal to what? mx2. M is what? 1 into x2. Same formula. mx2. M is 1. So we are substituting 1. mx2 plus nx1. What is n? 1. 1 into x1. Same formula, children. Same thing we are writing. This one only. The same thing. Okay, let me write it maybe here again. 1 minute. Let me just write it here. How do you find x? We need the ratio m is to n, which is 1:1 here. And the x coordinates x1 and y1. So, sorry, x1 and x2. And how do you find y? You need the ratio and the y coordinates, y1 and y2. Correct? M is to n is replaced with 1:1. So x is equal to 1 into x2 plus 1 into x1 by m plus n, 1 plus 1, which is x2 plus x1 by 2 or x1 plus x2 by 2. And y is equal to, I hope you're following, it's the same thing, not a new formula. Okay, here this is mn. Okay, m y2. M is 1, so 1 into y2 plus n y1, 1 into y1 by m plus n, 1 plus 1. So it's basically y2 plus y1 by 2, which can also be written as y1 plus y2 by 2. So if you know that C is the midpoint of AB, and we are asked to find only the x coordinate of C, you can only find x1 plus x2 by 2. You need not find, see, you can use them separately. That's what I'm trying to say. You can use x1 plus x2 by 2 and y1 plus y2 by 2 separately. They're two independent, expressions. Supposing you're asked to find only the x coordinate of C, find x using x1 plus x2 by 2. Finished. To find the y coordinate of C, where C is the midpoint of AB, y1 plus y2 by 2. They're two separate things. But if you have to find the coordinates of the midpoint, if you have to find the coordinates of the midpoint C, then you will find them separately and then you will write that answer together. Supposing you get 7 here and 5 here. So C is equal to 7, 5 like this. You'll put them together. Correct? One more thing. With respect to the distance formula, we'll also discuss. So see, we saw the distance formula. We saw the section formula, and using the section formula, we are able to find the coordinates of the midpoint of the line segment. Now, this one thing I didn't mention about the distance formula. We'll learn a simpler formula to find the distance of any point from the origin. I'm supposing you want to find the distance of a point from the origin. Okay, let me show the axis like this. And this is 0, 0. This is 0, 0. This is O. Origin is given by O, 0, 0. O 0, 0, right? Okay, and supposing there's a point here, A, which is say like -6, -4. Okay, now you want to find the length of the line segment OA. That is, you want to find the distance of point A from the origin. Both are the same. The length of the line segment OA is the same as the distance of the point A from the origin. Okay, so now in general, I'll just use in general, okay, I'll just say this is x1, y1. I'll just say this is x1, y1, and this is x2, right? Okay. So here it's going to be square root of, what's the distance formula? Difference between abscissa the whole square. Subtract the x coordinate and square it. Okay. Subtract the x coordinates. So x2 minus 0. So any order, no, we can subtract 0 minus x2, x2 minus 0. Both are the same. No, the whole square. When you square it, both are the same. So you can write x2 minus 0 the whole square or 0 minus x2 the whole square. Both are the same. Plus 0 minus y2 the whole square or y2 minus 0 the whole square. So there's nothing but square root of x2 square plus y2 square. So now in what they do, no, in general, they'll mark this, if this point is called x comma y. Now you can change the formula based on if this is called x comma y, then it will be square root of x square plus y square. If this point is called x1 and y1, it is square root of x1 square plus x2 square. Sorry, x1 square plus y1 square. So if you want to find the distance of a point from the origin, then whatever coordinates are given to you, of this point. So A, if it is x2 comma y2, then it's going to be square root of, this is important for 1 mark. You need to work faster, right? So it is x2 square plus y2 square. If this is x comma y, then it will be square root of x square plus y square. If this one is x1, y1, then it will be square root of x1 square plus y1 square. All right. You can see here, distance of a point from the origin. The distance of the point P x comma y from the origin is given by, this is the formula. So it's nothing but root of x square plus y square. Depends on what this is called. If it's called x1 comma y1, then it will be x1 square plus y1 square. If this is called m and n, then it is square root of m square plus n square. Correct? So direct applications, you can do it just substituting and calculating. Now look at this question. Find the values of y. Find the values of y for which the distance between the points A and B is 10 units. So what is given? A, B, A is 3 comma minus 1, B is 11 comma y. And what is AB? This distance equal to, or the length of the line segment AB is 10 units. Okay, so we are given that AB is equal to 10. And how do you find AB? Square root of x2 minus x1 the whole square. Subtract the x coordinates. So subtract the x coordinates. What is this? 3 or minus 3? One second. It's very easy if you remember like this. So subtract the x coordinates. 11 minus 3 the whole square. Plus subtract the y coordinates. So y minus minus 1. Minus minus 1. So plus 1 it will become. Because y, you should subtract y minus minus 1. So plus 1 the whole square is equal to 10. Okay, now square on both the sides. Squaring on both the sides. Because you want to get rid of the square root. So it will be 11 minus 3 is what? 8. 8 squared. 8 squared plus y plus 1 the whole square. Squaring on both the sides. I have the answer, I think, here. Okay, so we have the square. This one square root is gone. So 11 minus 3 the whole square is 8 square plus y plus 1 the whole square is equal to 10 squared. So now expand, solve and find the values of y. Please write down the question. Just leave, if you're using a long notebook, just leave 2 sides for the introduction. If you're using a long notebook, leave 2 sides for the introduction, 2 sides. One side, another side, that's all. Leave 2 sides for the introduction. Take down this question. Don't write question number 4, you write question number 1. Yeah. Two values for y, yes.
Y is equal to -7, y is equal to 10.
Correct. Perfect. Y is equal to -7 or y is equal to 5, correct? Yeah. Yeah, next one. That one you didn't expand it correctly, y plus 1 the whole square. Okay, then you missed to add 1, huh? That one you forgot. Okay, okay. You got the values correctly? No, looks like you made a mistake. What is the mistake? Like, no, you're right. Very good. Okay. Next one. If the point P is equidistant from the points A and B, find the values of K. Now, equidistant does not mean midpoint. Equidistant does not mean midpoint because see here now. Look at these 3 points. Please stop writing and listen to me. Now, supposing we have 3 points P, Q, and R. P, Q, and R. Okay. Now say the distance between the points P and Q is 5 kilometers. And the distance between the points P and R is also 5 kilometers. We have 3 points P, Q, and R. The distance between the 2 points P and Q is 5 kilometers. And the distance between the 2 points P and R is also 5 kilometers. So then we say that P is equidistant from Q and R. P, the point P is equidistant, equal distances, is equidistant from Q and R. So if P is equidistant from Q and R, we draw like this. P is equidistant from Q and R. If supposing A is equidistant from M and N. So A, then we'll show M like this, we'll show N like this. And these two distances are equal. A is equidistant from M and N. So that means AM is equal to AN. Okay. All right. So here, what do we have? Here, what do we have? Oh, we have the point P. Point P, which is given by K minus 1, 2. Okay, that's equidistant from the points A, 3, K and B, K, 5. Okay, now what from this question, what do we understand? PA is equal to PB, right? So take it that when it is equidistant, it's not midpoint. It's not midpoint. All right. Okay. So PA is equal to PB. So that how do you find PA? Square root of subtract the x coordinates. So K minus 1 is the x coordinate of P minus C. PA, no. So you should use the coordinates of P and A. For PB, you should use the coordinates of P and B. When you're working PA, use the coordinates of P and A. For PB, use the coordinates of P and B. Okay, so PA is equal to PB, we understood. 1 minute. So PA is equal to PB. How do you find PA? Square root of, subtract the x coordinates. K minus 1 minus 3. K minus 1 minus 3, the whole square, plus subtract the y coordinates. K minus 2, 2 minus k, both are the same. So whole square is equal to square root of PB. So use the coordinates of P and B. So K minus 1 minus K, the whole square, plus 2 minus 5 or 5 minus 2, whatever is your convenience, the whole square. Work this. Now when you square on both the sides, what will happen? The square roots will get cancelled on both the sides. Right, yeah, continue. Done, all of you? Yeah. All right. Any questions here? Javarshni? Okay. You can help yourself. Any doubts? So you should first write this condition. If the point P is equidistant from A and B, that means PA is equal to PB. Now, what is PA? PA means the length of the line segment PA, which can be found using the distance formula. PB is the length of the line segment PB, which can be found using the distance formula. Then when you square on both the sides, the square root is eliminated. Quadratic equation, split the middle term and find the values of K. Online children, any questions?
No, ma'am. No, ma'am.
Okay, children. Next one. Yeah. Find the relation between x and y such that the point P x comma y is equidistant from the points A and B. Similar working. Just work like the earlier one. Same. See, what's the condition? Again, PA is equal to PB is a condition. Work it exactly like you did the earlier one. Please work by yourself. Completed children online? Finished all of you? What's your answer? Why? No, you cannot find the values of x and y here. No, you cannot find x or y values here. You'll only get an equation. Correct. X squared? No. Correct. X plus y is equal to 3 or x plus y minus 3 is equal to 0. All right. Let me show you the answer. So see here. So children, there's something new here, so don't get confused. I've written the condition PA is equal to PB. Then you can square on both the sides here itself, children. PA square is equal to PB square. Please understand that. Without some, okay, so PA is equal to PB, which means PA square is equal to PB square. So when you write it here, no, don't write the square root symbol because PA square will not have the square root symbol. Is it confusing? Yeah, so you can also write it like this. For PA, you should write with square root. For PA square, don't put the square root symbol. So PA square is equal to PB square. So you don't have to put the square root symbol. And the rest is the same. Please check where you've gone wrong. Whenever you have to find a relation, you cannot find x or y values here. Just for you to remember, I'm telling you. Find a relation means you will get an equation like this. You will not be able to find x or y values. Here it's with one wrong symbol. No. X minus will be equal to. Okay, so let me cancel this y square also. Two x 17 minus 5. 1 and 4 is 5. 2x 2x 17 minus 8 2x 2x and 2x is not cancelled. And I'm not even able to minus 2x. No, plus 2x. That's plus minus 2x. Oh, so minus 4x and they have to cancel. How do you இங்க வந்து plus 2x தான். See your friends. This is x plus 1 the multiple. So here it will be plus 2x. That's x minus 1 the multiple. So here it will be minus 2x. Minus 2x and plus 2x. ஒரே பக்கத்துல minus 4x வரும். இல்ல இந்த பக்கம்ல plus 4x வரும். Yeah. So நீங்க வந்து இந்த plus 2x போட்டு இங்கேயும் plus 2x போட்டுருக்கீங்க. The minus 2x. Should I show you? That's right, yeah. Okay, so children, actually, that's why I didn't show you the slide. See, don't get confused. I have just transposed what I have done. Okay, just forget this working. Let me just continue working here. Okay. We'll just understand PA square is equal to PB square and we'll continue. PA, sorry. So we have PA is using the coordinates of P and A. So x minus 1 the whole square plus y minus 4 the whole square is equal to x plus 1 the whole square. Because we'll have to subtract plus y minus 2 the whole square. So x squared minus 2x plus 1 plus y squared minus 8y plus 16 is equal to x squared plus 2x plus 1 plus y squared minus 4y plus 4. Signs, be very, very careful. Now we'll simplify the left-hand side. So you can cancel actually x squared and y squared on either sides, they get cancelled. X squared and y squared on either sides, they get cancelled. Then on this side, you have minus 2x minus 8y plus 17 is equal to 2x minus 4y plus 5. Bring all of them to one side. Minus 2x minus 8y minus. Let me write the x and x together. So minus 2x minus 2x minus 8y plus 4y plus 17 minus 5 is equal to 0. Minus 4x minus 4y plus 12 is equal to 0. Divide by minus 4 throughout or 4 throughout. Okay. You can also change the signs throughout now. When you change the signs throughout, you'll get minus 4x becomes plus 4x. Minus 4y plus 4y. Plus 12 minus 12 is equal to 0. Now you can divide by 4 throughout. So you'll get x plus y minus 3 is equal to 0. So whenever you have to find a relation between x and y, you'll always get an equation like this. You are not asked to find you cannot find the values of x and y. That's the difference between this question and the earlier question, where we were able to find two values for x or y. So you can just write x plus y minus 3 is equal to 0 is the required relation. Is the required relation between x and y. Between x and y. Online children, any questions? Please ask me. Done, children? All of you? Next one. Find the points on the x-axis, each of which is at a distance of 5 units from the point A, 5, 3, minus 3. So you'll have to find points on the x-axis, each of which is at a distance of 5 units from the point A, 5, minus 3. Let's first understand what the question means. Okay, so we'll plot this point A on the Cartesian plane. So like this, where is 5, minus 3? 5 minus 3 somewhere here. 5, minus 3. Okay, so now see, you can find. Ready? So this is the x-axis. This is the x-axis. You need to find the address of the point P and Q lying on the x-axis because it's given you find the points on the x-axis. So you need to find the address of the points P and Q lying on the x-axis, which are at equal distance from this point A. Because here, find the points on x-axis, each of which is at a distance of 5 units from the point A. So that means AP is 5 units. AQ is also 5 units. We'll come again, see here. X-axis and y-axis. 5, minus 3. So 5 and minus 3 roughly here. A, 5, minus 3 lies in the 4th quadrant. Now we have to find the points on the x-axis. So say we have to find the address of point P and point Q. What is the distance between A and P? 5 units. What's the distance between A and Q? 5 units. Okay. So this is what it is. We need to find the address of these 2 points on the x-axis, which are at a distance of 5 units from A. To say the question 2-3 times, then only the question is clear. We have to find the address of these 2 points P and Q. Where are the points P and Q? They are on the x-axis. So we need to find the address of P and Q lying on the x-axis, which are at a distance of 5 units from this point A, located in the 4th quadrant. Okay. I'll just draw this figure in the rough column later. For now, it's enough if you show a figure like this. This is the point on the x-axis. Let's call it P. And you know that every point on the x-axis is of the form x, 0. A, 5, minus 3. Distance 5 units. Now for x, when you work this, for x, you will get 2 values. And hence you can find the 2 points. So you don't have to take a figure like the one I used to explain. நான் எக்ஸ்பிளைன் பண்றதுக்கு ஒரு ஃபிகர் வரைஞ்சல அந்த மாதிரி ஃபிகர் எடுக்க வேண்டாம் நீங்க இப்படி எடுத்தாலே போதும். இது வர்க் பண்ணிச்சேவே உங்களுக்கு xக்கு 2 values வந்துரும். And so you can find the 2 points. Like if you get x is equal to 2 and x is equal to 7, 2, 0 is 1 point, 7, 0 is the other point. Because they lie on the x-axis, so it will be x, 0. You'll get 2 values for x. You can even get a negative value, like on the negative side of the x-axis. So then minus 2, 0 and 7, 0 are the 2 points. So take a figure like this. Okay, so what is this point A? It's given here, 5, minus 3. நீங்க அதை இங்க ஃபர்ஸ்ட்ல கூட போட்டுக்கலாம். இங்க தான் A போடணும்னு கிடையாது. See, you can also take the figure like this. You can take A here also. A is what? 5, minus 3. Then this is what? P, x, 0. This one represents the point on the x-axis. And any point on the x-axis of the form x, 0. What's the distance between these 2? 5 units. Okay, that means AP is equal to 5. You can also write AP square is equal to 5 square, 25. Okay, 5 square, 25. Now, how do you find AP square? Distance between the difference between the x coordinates. So x minus 5 the whole square plus difference between the y coordinates. 0 plus 3 the whole square. Square root symbol போட வேண்டாம். Is equal to 25. இதை work பண்ணுங்க. Yeah.
X equal to -8, actually equal to -1.
I'm sorry. Yeah, please tell me again.
-8, -1.
Minus 8 comma minus, no, just the two values of x are minus 8 and minus 2, is it? No? Correct. No, we'll do together. Srivatsan, இது வரைக்கும் கரெக்டா இருக்கா? நான் இப்போ எழுதியிருக்கேன் இது வரைக்கும். ஓகே, இதுக்கப்புறம் என்ன எக்ஸ்பேண்ட் பண்ணு?
X square plus 1.
X square minus 10x, no? X square இல்ல இப்ப எனக்கு சொல்லுங்க, x square plus 10x minus 10x இல்லமா? ஐடென்டிட்டி புக்கு பார்க்குறேன் வேற இல்லை. Plus 3 squared is 9. 0 plus 3 is 3 and 3 squared is 9. This is equal to 25. So 25 on either side will get cancelled. So now this is x squared minus what's the fun? Where is, okay. So we'll go back to the question again. Now this point A is located in the fourth quadrant, 5 comma minus 3. We have to find the address of the points on the x-axis. We have to find the address of the address, meaning the coordinates of the points on the x-axis, which are at a distance of 5 units from A. Now we know that every point on the x-axis is of the form x comma 0. Any point you take on the x-axis, it will be of the form x comma 0. So see the representation. We have taken point A, 5 comma minus 3, and the point P, which is on the x-axis, with address x comma 0. Distance between A and P, 5 units. Correct? Now AP is 5. So AP square is 25. Then the distance formula, quadratic equation, we solve, and x is 9 or x is equal to 1. Now what is the address? X comma 0. So rend address for the namakku. 9 comma 0, because address on the x comma 0. And x is rend values. So 9 comma 0 and 1 comma 0. So these are the 2 points on the x-axis, which are at a distance of 5 units from this point A, which lies in the fourth quadrant. So please ask me, say online children, any questions, ask me. Here, the class, yeah, Srivatsam running. Others? Even the A plus B, the whole square formula use for you. A square plus B square plus 2AB தானே பின்ன அது A minus போட்டு நீங்க மைனஸையும் போட்டு இங்கேயும் மைனஸ் போட்டு அதுதான் பிரச்சனை. The A plus B the whole square formula யூஸ் பண்ணா A square plus B square plus 2AB தானே போடணும். A minus B whole square. அப்ப minus 2AB na B is 5 only, no? Why you put minus 5? X minus 5 the whole square. இதை A minus B the whole square compare பண்ணா A வந்து X மைனஸ்க்கு மைனஸ் இங்க இருக்கு. B is equal to 5. X minus 5 whole square. A minus B whole square. A is X. Minus to minus இருக்கு. B is equal to 5. Or you can write minus B is equal to minus 5. So B is equal to 5. That's very wonderful. Done, children? Next one. Find the points on y-axis, each of which is at a distance of 13 units from the point A minus 5 comma 7. All smiles, Jayavashini. Okay, So point A minus 5 comma 7. Okay. And we know that every point on the y-axis is of the form 0 comma y. Now let's call this P. The distance between A and P, 13 units. Okay, so which means AP is equal to 13 or AP square is equal to 169. So distance between the difference between the x coordinates, 0 plus 5. So because 0 minus 5 plus y minus 7, the whole square is equal to 169. Please work this. Completed? Yeah, what are the values for y? 19 and minus 5. Yeah, correct. 19 or minus 5. Okay. So we have this point minus 5 comma 7, which actually lies on the second quadrant. Okay. Now we need to find the address of the points on the y-axis. We need to find the address of the points on the y-axis which are at a distance of 13 units from this given point A. Correct? So this representation is enough, children, this one. So A minus 5 comma 7. Then this is the point on the y-axis, which is given by the address 0, y. Distance between them 13 units. So AP is 13, AP square is 13 square, which is 169. So then the distance formula, right? So 0 plus 5 is 5, 5 square is 25 plus y square minus 14y. You can bring 169 also to this side. Minus 169 is equal to 0. So we have y squared minus 14y. 169 and 49 is minus 120 and plus 25. So minus 95, right? What? Minus 95 is equal to 0. So 19 5s are 95. 19 5s are 95. So minus 19y plus 5y. Minus 95 is equal to 0. You can also use a quadratic formula if you want. If you were not able to find the factors. So y into y minus 19 plus 5 into y minus 19 is equal to 0. Sorry. Ouch. Sorry. Not concentrating. See, 0 comma minus 5 and 0 comma 19. Right? Yeah. Online children? Please let me know if you're finished. Online children, use the emoji, raise your hand. Aniruddhan, disable your mic. Yeah. So we have Pratish, Hariprana, Blessy, Tanishka, Ritsa, Shakti, Krishnapriyan, Aragamai, Sabarna, Sadhana, Aniruddhan. Okay. Any questions? Okay. So I repeat, we are given 1 point A in the Cartesian plane. We know the address of A. Now we have to find the address of the points lying on the y-axis. So how will the address of a point lying on the y-axis look like? 0, y. Okay. So we need to find the address of the points on the y-axis, which are at a distance of 13 units from A. So represent the information like this. So from this, AP is 13, squaring on both the sides, AP square is 169, use the distance formula. So you get a quadratic equation and two values for y. So using the two values for y, you can write the address of the 2 points. Correct? Okay. Every question is different. Find the point on the x-axis, which is equidistant from this and this. So there is a point P on the x-axis given by the address x comma 0, and that is equidistant from A 5 comma minus 2 and B minus 3 comma 2. Finished. Yeah, what are the values? No. Find the point. Yes. What's the value of x? 12 comma 0. 1 comma 0. Correct. Got it? Correct. So to find PA square, you should use the points P and A. Don't put the square root symbol. Subtract the x coordinates. So x minus 5, the whole squared plus. Subtract the y coordinates. So it will be 0 minus minus 2. Gone down somewhere, Renu? Instead of? Instead of? You found your mistake? Okay, fine. No, I didn't get you actually. Okay, you found your mistake, right? Okay. Doubts? யாரும் இப்படி சாஃப்டா பேசுங்க. ஓ கேர்லெஸ்ஸா தப்பாயிட்டீங்களா இல்ல புரியலையா? கேர்லெஸ். நீங்க எக்ஸ்பேண்ட் பண்ணது கரெக்டா இருக்கா? x minus 5 the whole square not that? If you online children completed this one?
Yes, ma'am.
Yes, ma'am, completed.
Yes, ma'am.
Okay. Found your mistake, Jayavashni? Complete and tell me. Okay. Find the point on the y-axis, which is equidistant from the points minus 5, 2 and 9, minus 2. Finished? 0,7. Which is right. Yeah, she's right. Okay. Yeah, Jayavashi, tell me, how do you work this? Yeah, no, tell me how do we work this? Close your book and look at the board and tell me. 0 plus 5 minus 2 whole square is equal to okay, good. -25 minus 4. Okay. Y squared gets cancelled on both sides. Plus 4 on either sides gets cancelled. So we have minus 4y here, and you're going to transpose this, right? So minus 4y is equal to 81 minus 25. So minus 8y. Very good. Thank you. Is equal to 56. Okay. So y is equal to minus 7. Y is equal to minus 7. So therefore, P 0, minus 7 is the required point. On the y-axis. That you know, on the y-axis. All right. Online children, is this clear? Online children. Okay. Every point on the y-axis is of the form 0, y. Every point on the y-axis will be of the form 0, y. And we are given 2 points, A and B. And this point on the y-axis is equidistant from A and B. So the condition is, if the point on the y-axis is P, then PA is equal to PB is the condition. You should write that first. Then squaring on both the sides, PA square is equal to PB square. And after that, it's very simple. Just use the distance formula, get a quadratic equation. No, not a quadratic equation here, sorry. You're able to work and find the value of y, and hence you find the point. Okay, next one. This will take some time, so one minute. Let me see if I can take a simpler one. No, all these are time consuming. Okay, is it already 9:30? No, we have 3 minutes. I think we can try to finish this one. The others will take a longer time, some 10-15 minutes. So we'll just do this one. Show that the points A, A, minus A, minus A, and root and minus root 3A, root 3A are the vertices of an equilateral triangle. Find its area. Okay. So let A, B, C. We'll just do this together. Or if you can listen and write, fine, you can write. But I'll share the image. If you're not able to complete, I'll share the image on WhatsApp. So Okay, now let's find AB. Well, how do you find AB? Square root. See, now you should not find AB squared. You should find AB only. When you have an equation, like AB is equal to CD, then you can write AB square is equal to CD square. Here you should not find AB square. You should find AB only. AB is equal to square root of, subtract the x coordinates, a plus a the whole squared, plus subtract the y coordinates, a plus a the whole squared. So it is square root of 2a the whole squared plus 2a the whole squared. So it is square root of 2a into 2a is 4a squared plus 4a squared, which is square root of 8a squared. Now a square comes out of the square root as a. And what is root 8? 2 root 2. Root 8 is 2 root 2. A square comes out of the square root as a. So 2 root 2 a units. All right. Now let's find BC. BC is equal to square root of, subtract the x coordinates. So it will be minus a plus root 3a the whole square plus minus a minus root 3a the whole square. All right. I can use an identity here, but since it's time, I'm not using that. So when we expand this, take a as minus a and b, 1 second. I have to tell you that, 1 second. Listen to this. So square root of, this can be written as root 3a minus a the whole square, right? Plus, here what you can do is, see here, please look at this, correct? Now between these two, can I take minus common? Then can I write a plus root 3a like this? See that whole square I've put, okay? Now minus a minus root 3a, I'm taking minus common. So minus into a minus into plus minus root 3. So what am I doing? See here, that whole square is here. The whole square is here. Now inside we have two terms. No, we are taking minus common. Minus a minus into plus is minus root 3a. So next step, what happens? Root 3a minus a the whole square plus this minus is squared, no, so it becomes plus. And inside the bracket, what do you have? A plus root 3a. Can we write it as root 3a plus a the whole square? Minus is squared, it becomes plus. And inside the bracket, we have a plus root 3a, which can be written as root 3a plus a. Now you can use the identity. What is this? This is like a minus b the whole square plus a plus b the whole square. It's 4ab. Okay, so this is of the form, x minus y the whole square plus, oh, it's plus in the middle, sorry. So it's of the form x plus y the whole square plus x minus y the whole square, which is 2 of x square plus y square. I'm sorry. It's a minus in the middle. So because I made that mistake, let me just write the two identities. What are the two identities? X plus y the whole square minus x minus y the whole square is equal to 4xy. But x plus y the whole squared plus x minus y the whole square is equal to 2 of x square plus y square. We are using this one because we have x plus y the whole square plus x minus y the whole square. Okay, so it is you should put the square root symbol. Okay, now it is 2 of x squared. What is x squared? Root 3a the whole square. root 3a the whole squared. 2 of x squared plus y squared plus. This is correct. 2 of x squared root 3a the whole square plus y square. So this is nothing but square root of 2 into what is root 3a into root 3a, 3a squared. Root 3 into root 3 is 3a squared plus a squared. I'll just write it here is equal to square root of 2 into 4a squared. Correct? I'll just continue this part here, okay? Just continue here. So it is 4 will come out of the square root is 2. 4 comes out of the square root is 2. 2, but that 2 remains under the square root. So root 2, a units. 4 comes out as 2, but the 2 remains under the square root and a square comes out as a. So 2 root 2a units. So AB is 2 root 2a units. BC is also 2 root 2a units. Correct? Now we'll have to find AC. Children, it's time, so I'll just stop. So like this, we'll have to also find AC. You can see if you can use the identity like we used here to find AC. So you will get 2 root 2a there also. So you must say AB is equal to BC is equal to AC. All the three sides or all the three line segments have the same length 2 root 2a. So it's an equilateral triangle. And how do you find the area? Formula. Root 3 by 4 into side square. Root 3 by 4 into side square. So root 3 by 4 into what is the side? AB is a side, BC is a side, AC is a side. What's the side? 2 root 2a. So root 3 by 4 into side square. Root 3 by 4 into 2 root 2a the whole square. Will give you the area of the triangle. So how do you show that they are the vertices of an equilateral triangle? We are given 3 points, right? How do we show that these 3 points are the vertices of an equilateral triangle? Just name the points A, B, C or P, Q, R and find like we named it ABC. So we find AB, we find BC, we find CA or AC using the distance formula. Using the distance formula. So everywhere we get 2 root 2a units. So since all the 3 line segments have the same length, the 3 line segments form the sides of an equilateral triangle. All right. And then find area. Formula to find area of an equilateral triangle, root 3 by 4 into side square. And what is side? 2 root 2a. That's it. All right. So I have the answer. I'll just share this image on WhatsApp with you later. So I've used the identity you can see here. See here. X minus y the whole square plus x plus y the whole square is equal to 2 of x square plus y square. When you find AC also, x plus y the whole square plus x minus y the whole square is equal to 2 of x square plus y square. We've used the formula. So everywhere it is 2 root 2a, 2 root 2a, 2 root 2a. AB, BC, AC all 2 root 2a. Hence equilateral triangle. Area root 3 by 4 into side square. Root 3 by 4 into. I'll share this image, okay? All right, children. So that's it for today's session. Thank you so much. Good night. Online children, you can leave the call.
Thank you, ma'am.
Thank you. Good night.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, children. See you.